Hi students, hope all of you are fine. This is the last part of the first chapter. Today we will learn about the characteristics and uses of F block elements. Let's start the class. F block elements. Students, you have already learned about the position of F block elements in the periodic table, haven't you? So let's learn what are F block elements. F block elements are elements coming after lanthanum and actinium and are placed in two rows at the bottom of periodic table. Did you see the two rows at the bottom of periodic table? Yes, they are F block elements. Why they are called F block elements? Because the last electrons are filled up in the F subshell, that is anti-penultimate shell. Anti-penultimate means the shell which lies inner. So, the F block elements consist of two series and the elements in the first row are called lanthanides or lanthanoids. These elements belongs to 6th period of periodic table. And the elements in the second row are called actinides or actinoids. These actinoids belongs to 7th period of periodic table. Remember the period of lanthanides and actinides. The lanthanides of 6th period and actinides of 7th period are generally known as inner transition elements. Let's learn the characteristics and some uses of F block elements. Like D block elements, most of the F block elements show variable oxidation state, and most of the actinoids are radioactive and they are artificial elements. Elements like uranium, thorium and plutonium are used as fuels in nuclear reactors, and most of the F block elements are used as catalysts in the petroleum industry. Did you understand? Okay, now we will go through some important questions from this chapter. See, a part of periodic table is given below and the symbols given in the column are not real. Now try to answer for the following questions. First question. List out the elements of S block. You know, S block consists of two groups, right? Group 1 and group 2. So what is the answer? Yes, A and B are the elements belongs to S block. Second question. Which elements show +2 oxidation state? Think about which group elements show +2 oxidation state. Yes, you are right. Group 2 elements. That is, B shows +2 oxidation state. Then third question. Which element contain 5 electrons in the outermost shell? Did you get the answer? Yes. E shows 5 electrons in the outermost shell. Next question. Name the element which has 5p electrons in the outermost shell. 5p electrons. It means it belongs to group 17. Right? Which are the elements in which the last electron enters the D subshell? So you have to look at the D block elements. Which are they? C and D. Got it? Next question. Which element has the highest ionization energy? You know, ionization is greater in the right side of the periodic table. So which among the elements show highest ionization energy? Yes, group 17, right? So name the element G. Got it? See the next question. Which is the highly reactive nonmetal? Nonmetals are present on which side of the periodic table? Right side. So name the element G. Okay. And the next question. Which element show -2 oxidation state? From this question it is clear. -2 means its oxidation state. So valency 2, that is group 16. Write the chemical formula of compound formed between A and G. See, A is a group 1 element and its valency is 1. and G belongs to group 17, its valency is also 1. So how will you write the formula? We have to write the electropositive first, then electronegative, interchange their valency, we will get A and G. It is written as Ag. Right? This one we have learned in 9th standard. Now, try to answer this question. If the outermost configuration of an element X is 3s2 and that of Y is 3s2 3p5, could you write the chemical formula of compound formed between X and Y? And also you have to label the oxidation state. From this question, it is clear that 3s2, that means it belongs to group 2. And the configuration with 3s2 3p5, it belongs to group 17. Right? You know how to find the block and group number if you find the block. Now you have to find the valency of these two elements. What is the valency of X? The valency of X is 2 and that of Y is 1. Right? Now you have to write the electropositive element first, which is the electropositive X. So write X2, then Y1. Next step is to interchange their valency. So you will get X1, Y2. So what is the answer? Instead of writing X1, we can write XY2. Is that clear? So let's revise the chapter once again. So what all things we studied in this chapter? We studied about subshells, how to write the subshell electronic configuration, then peculiarity of configuration of chromium and copper, and how to find the period, block and group of an element, then characteristics of S, P, D and F block elements. Okay students, this was the whole recap of this chapter. Hope you understood well. Thank you.